So this is going to be the sixth video in the series on graphing equations, or so graphing lines. So this video is going to focus on slope. Okay, so in one of the previous videos, I kind of was prepping you for slope. Okay, I mentioned when we were talking about the point plotting method for graphing, I was describing what the table of values was telling us about the change in x compared to the change in y's. And that's really just the slope of a line. So here's where you're officially going to learn about the slope of a line. Okay, so let's see. Okay, so this video is all about slope. All right, so the slope of a line describes the steepness of the line. Okay, so when you're dealing with slope, it tells you how steep a line is. Okay, so another way to think about slope is rise over run. So this right here shows the relationship of the vertical change. Whoops, I can't spell. It shows the relationship of the vertical change in the line compared to the horizontal change in the line. So the vertical change is the rise, the horizontal change is the run. And so basically the slope is the ratio of the vertical change compared to the horizontal change. So what we have is the rise over the run, quite literal division. You look at how much the rise, the run, wow, how much the line rises compared to how much it has a run. So basically you look at the vertical change divided by the horizontal change. So it's the vertical change divided by the horizontal change. And what does that mean for us very specifically in terms of a graph? Well, for us, the vertical change is the change in y. The horizontal change is the change in x. Okay, so that's what we're looking for. The slope of a line describes the steepness of the line. More specifically, it shows a relationship between the vertical change to the horizontal change in the line. Now, slope is also denoted by a lowercase m. All right, so if I was going to write this out officially, we would say that m equals the change in y's versus the change in x. So I would say y equals, or m equals y2 minus y1 divided by x2 minus x1. And it's for any 2 points, x1, y1, and x2, y2 on a line. Okay. So slope represents the steepness of a line. It shows the relationship between the vertical change in the line compared to the horizontal change in the line. Quite literally, slope is the ratio of the change in y's to the change in x's. It's denoted by a lowercase m, and the official formula that you're going to have to know is this right here. So the slope is equal to y2 minus y1 divided by x2 minus x1 for any 2 points x1 and x1 y1 and x2 y2 on a line. And that's 2 words. It looks like one. All right, so let's go ahead and just kind of look at this. So if we're talking about the slope of a line, let's say we have this right here. So let's say I have a line that does this. okay, compared to a line that does this. Right away, you can see that the blue line is significantly steeper than the red line. So let's look at it. So basically, to get from the origin of the line to this point right here on the line, we went up 1, 2, 3, 4, 5. So the rise was 5, and the run, the horizontal change, was 1. So we have a slope of just 5. Now for the red line, what we did is we went to the right 1, 2, 3, 4, 5. Well, it looks like it's 1, 2, 3, 4, 5, 6. All right. So we went to the right 6. That's the run. And then we went up 1. So we have a slope of 5 versus a slope of 1/6. So when you're looking at the slopes, the bigger the number, the steeper the line. The smaller the number, the shallower or less steep the line. Now let's look at this again. But in this case, we're going to look at it a little different. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's say for our first line, we go up 3 to the right 1. So we have this line right here. And then we have a line where we go to the left 3 and then up 1, like this. So again, you can see that the blue line is significantly steeper than the red line. But let's talk about this in numbers. So for the blue line, we went up 1, 2, 3. But then we went to the left 1. And remember, if you go down or to the left, that's a negative. If you go up or to the right, that's a positive. So this slope right here is -3. Now for the red line, we went to the left 1, 2, 3. So the denominator, the horizontal change, is -3. And then we went up 1. So the rise, or the numerator, or the change in y's, is +1. So we have two slopes here, 3, which is a larger number, versus 1/3, which is a smaller number. The slope that has 3 is steeper than the slope of 1/3. What's different about the graph on the left compared to the graph on the right is the direction in which the lines are going. So on the left, the slopes are positive, and the lines rise, which just means they go up or increase from left to right. Now, if we look at the graph on the left, they have negative slopes, and the lines fall. That just means they go down or decrease from left to right. So a couple of things that you need to know about slope is the larger the number, the steeper the line. The smaller the number, the flatter the line. Also, positive slopes versus negative slopes. If you have a positive slope from left to right, your line is going to be going uphill, okay? If you have a slope that is negative from left to right, your line is going to go downhill, okay? So just a quick recap. Slope it describes the steepness of a line. We think of slope oftentimes as rise over run because it shows the relationship of the vertical change in the line compared to the horizontal change in the line. So we can quite literally think of this as rise over run equals vertical change over horizontal change, or more simply put for us as far as graphing is concerned, it's the change in y divided by the change in x. The actual formula, and I'm going to get back to this formula in just a minute, the actual formula to calculate the slope, assuming you have 2 points, x1, y1, and x2, y2 on a line, the slope of that line can be found by m equals y2 minus y1, which is just the vertical change in the line, divided by x2 minus x1, which is the horizontal change in the line. I then showed you images here. So you've got two positive slopes. One's really steep, one's not very steep at all. You can see that the steep line has a much higher number than the line that's not steep, and that's always true. The higher the number, the steeper the line. And then we have another graph where we see two slopes, two lines that have negative slopes. And what we can see about those lines is they go downhill. So positive slopes, uphill, negative slopes, downhill. The larger the slope, the steeper the line. And the smaller the slope, the less steep the line is going to be. So now let's actually practice calculating slope. So we're just going to calculate this given ordered pairs. The thing I would caution you about the absolute most is watch your signs. Okay, so recall the formula for slope is y2 minus y1 over x2 minus x1. So these little subscripts of 2's and 1's on the y's and x's, they just denote which ordered pair that coordinate comes from. The order of y2 minus y1 doesn't matter. We could simply write this y1 minus y2 as well. However, if we wrote it y1 minus y2, we would have to invert the x's too. We would have to say x1 minus x2. So the order matters in the sense that however you start with the y, you have to start there with the x2. So let's look at some examples. So we want to find the slope of all of these lines. So for the first line, I have 2 points, -1, -5, and 2, 1. So I want to know the slope of the line that goes through these 2 points. So find the slope of the line through each pair of points. Okay, so let's just label these just for the sake of being consistent. Let's say this is x1, y1, and this is x2, y2. So when I calculate my slope, I'm going to take y2, which is 1. I'm going to subtract y1, which is -5. So be careful, you're subtracting a negative here. And then I'm going to take x2 and I'm going to subtract x1. Again, you're subtracting a negative. Now, a lot of people sometimes forget how the sign rules work, but when you subtract a negative, you basically have to undo the subtraction, and you can't just willy-nilly convert subtraction to addition. Instead, you always add the opposite. So the first number stays the same, and then I add the opposite of the second number. So subtracting a negative, in short, just turns into addition. So I really have 1 plus 5, which is 6, over 2 plus 1, which is 3, and you always want to simplify. So in this particular case, the slope of the line that goes through -1, -5, and 2, 1 is 2. So let's look at another example. Let's say in this case, we have -2, -3, and 5, 2. So again, we'll label the points just to be consistent. And we take the difference in the y's. So I'm going to do y2, whoops, which is 2. I'm going to subtract y1, which is -3. Again, watch those signs. And then I'm going to take the difference in the x's, which is 5 minus -2. Again, I've got subtracting a negative, so I get 2 plus 3 all over 5 plus 2. So I get 5 over 7. So I have a slope of 5/7 here. Now, in both of these examples, the slopes were positive. All right, so if I were to draw these two lines, both lines would be going uphill. In fact, let's just do a quick sketch. So for the first example, I had the point -1, -5. So from the origin, I go to the left 1, down 5. And then from the origin, I go to the right 2, up 2, or up to the right 2, up 1. And look, if I sketch this line, I have a slope of +2. Now, let's look at that a little bit. So for this line, I technically go up 1, 2, 3, 4, 5, 6, and then I go over 1, 2, 3. Okay, this line is not drawn very well, but let's pretend. We'll fix it a little bit. I had one of my points kind of off. So basically what happened is I went up 6 and then I went to the right 3. So if I look at this a little closer, my slope could be looked at as the rise of 6, the run of 3, but at the end of the day, I still get plain old 2, and you can see that that line definitely goes uphill. Now let's look at the other example. So again, I'm just going to sketch points here so you can see. So for the first point, we had -2, -3. So from the origin, I'm going to go to the left 2, down 3. And then back to the origin, I'm going to go to the right 5, up 2. So here's my line. And you can see to get from one point to the next, I had to go up 1, 2, 3, 4, 5. And then I had to go to the right 1, 2, 3, 4, 5, 6, 7. So again, my rise was up 5, my run was to the right 7. So looking at the graph of both examples, I get the same value I got algebraically. All right, but it's just generally quicker to go ahead and do the algebraic method to find your slope than to try to graph the 2 points and count. But either way, you can see what the slope looks like visually, you can see the numerical process, and you can see that both slopes were positive and both of our lines in this case were in fact going uphill. Let's look at more examples. So next up, we have the points 3, 2, and -1, 10. So same directions as before. We're going to find the slope of the line through each pair of points. So I should have switched back to black ink, but no big deal. All right. So for the slope, I'm going to take the difference in the y's. So 10 minus 2 over the difference in the x's, -1 minus 3. 10 minus 2 is 8. -1 minus 3 is -4. I simplify and I get -2. Let's look at this one graphically, just like we did the previous examples. So I'm going to plot the 2 points and we're going to kind of count and see. Also, we have a negative slope here, so we're expecting our line to go downhill. Let's verify. 10, 10, 10. All right, so the first point was 3, 2. So at the origin, I go to the right 3 and up 2. At the origin again, I go to the left 1 and then up 10. So we connect, and you can see already that this line is definitely going downhill, which is what we would expect. All right. Now let's look from one point to the next to see what we get. So let's say we go from this point right here, we go up 1, 2, 3, 4, 5, 6, 7, 8. And then I go to the left, 1, 2, 3. Well, I go back 1, 2, 3, 4. So if I look at the rise and the run, I went up 8, I went to the left 4, and that simplifies to -2. That was a negative up there. So you can see everything matches. Make sure you put the negative right here on this 2. When I was writing it, I slipped and missed it. All right. So negative slopes, the line goes downhill, and you can again see kind of visually what's happening. So that'll be the last one for a few examples where we look at the graph. We're just going to practice the formula for now. And then at the end, we'll look at a couple of special examples. Okay. So let's say for this example, we have the points 7, 3 and 0, -11. So let's say this is x1, y1, x2, y2. You certainly don't have to label the points. I find for beginner students, it's usually a little bit easier for them to go ahead and label the 2 points. Now for the slope, we want the difference in the y's. So y2 minus y1. The difference in the x's, x2 minus x1. Well, negative 11 minus 3 is negative 14. 0 minus 7 is negative 7. We want to simplify that out. So the final slope is going to be positive 2. Negative 14 divided by positive 7 is positive 2. Wait, I said that wrong. Negative 14 divided by negative 7 is positive 2. Let's keep looking at examples. Now we have negative 1, negative 3, and 2, 2. So again, let's label. I get x1, y1, x2, y2. We want the difference in our y's, so y2 minus y1 divided by x2 minus x1. Watch that subtraction of a negative. The biggest mistake that happens with slope is sign errors. So 2 minus negative 3 is just 2 plus 3. 2 minus negative 1 is 2 plus 1. So we get 5/3. All right. Let's look at another example. I think I've got room for one more on this slide. So for this one, I have negative 3, 3, and 3, negative 1. So we'll label x1, y1, x2, y2. And then we want the difference in our y's, so negative 1 minus 3. So I take y2 minus y1, and then I take x2 minus x1. Well, 1 minus 3 is negative 1 minus 3 is negative 4. 3 minus negative 3 is 3 plus 3. So I have negative 4 over 6. I always want to reduce or simplify. Now I've got a negative divided by a positive, so my slope is going to be negative. But then 2 and 6, or 4 and 6 have a 2 in common, so this reduces to negative 2/3. All right. Let's do 2 more regular examples, and then we'll look at 2 more special examples. So same directions, find the slope of the line through each pair of points. So I've got 7, negative 2, and 4, 3. So let's label, let's say this is x1, y1, x2, y2. So I'm going to take the difference in my y's. So y2 minus y1, watch your signs, x2 minus x1. Well, 3 minus negative 2 is really just 3 plus 2. And then 4 minus 7 is negative 3. So I get 3 plus 2 is 5 over negative 3. Now, here's something that I want you all to know. If I have m equals negative 5/3, I just have the negative out front. That is exactly equal to negative 5 over 3, which is exactly equal to 5 over negative 3. So it doesn't really matter if you have just a single negative. It doesn't really matter where you put the negative. Just make sure you put it somewhere, because a lot of times what we're going to do is we're going to apply a slope in the next 2 videos, and you want the negative either in the numerator or the denominator, so just put it wherever. Now on the flip side, if I had m equals negative 5 over negative 3, that is exactly equivalent to 5 over 3. So keep in mind, you can change both signs. All right. So the negative 5 becomes positive 5, but if that's the case, the negative 3 has to become positive 3. Okay. So just be really careful when it comes to your signs. Okay. And it will matter when we start graphing using a slope, but we'll talk more about that when the time comes. All right, one more example, and then we'll look at the special cases. For this one, let's say I have negative 4, negative 1, and 2, 3. So again, let's label just to be clear. So I want the difference in my y's, so y2 minus y1, all over the difference in my x's, so x2 minus x1. Watch your signs. 3 minus negative 1 is really 3 plus 1. 2 minus negative 4 is 2 plus 4. So I get 4 over 6. Now, both 4 and 6 are positive, so we'll just leave this positive, but I do want to reduce. 4 and 6 have a 2 in common, so I divide each by 2, and I get positive 2/3. Okay, so there you have it. That's just the basics of how to calculate a slope. Now, on the last screen, I want to show you 2 special cases. Okay, so in the first case, we have 2 points, 2, -1, and 5, -1. So let's label x1, y1, x2, y2, and we're going to find our slope. So we want the difference in our y's, so -1 minus -1. Difference in our x's, x2 is 5 minus x1 is 2. Well, -1 plus -1, or let me say that again, -1 minus -1 is really -1 plus 1. 5 minus 2 is just 3. Well, -1 plus 1 is 0. 0 over 3 is 3, which is 0. So let's look at this graphically. Let's see what's happening here. Okay. All right, so we're going to plot the 2 points at the origin. I'm going to go to the right 2, down 1. And then at the origin, I'm going to go to the right 5, down 1. What do we notice about this line? Let me actually do it in blue. What do we notice about this blue line? Hopefully you can see that this is a horizontal line. So horizontal lines all have a slope of 0. And if you look at the rise over run situation, in this case, we had a rise of 0, a run of 3. So this rise of 0 right here tells me that I'm not going up at any point. I'm just continuing this horizontal change, okay? And what I would also like for you to notice is when you look at those ordered pairs, what do you notice about the y's? They're exactly the same. So all horizontal lines are going to have 0 slope. So m equals 0 goes with a horizontal line. Don't say no slope. The line has a slope. It just has a value of 0, okay? So second special case, we have the ordered pairs 3, 5, and 3, -2. So we'll label the points. And we want to calculate our slopes. We want the difference in our y's. So y2 minus y1 over the difference in our x's. So x2 minus x1. -2 minus 5 is -7. 3 minus 3 is 0. And this goes way back to something you would have learned ages ago. What happens when we divide by 0? What do we get? Well, we already know from the previous example right here that if I take 0 and I divide it by a number, I get 0. The same is not true if I take a number and divide it by 0. This is actually undefined. So let's look at this to see what is visually happening. All right, so the first point, I start at the origin, I go to the right 3, and then I go up 5. The second point, I go back to the origin, I go to the right 3, I go down 2. Let me go back to blue so this doesn't get confusing. And then if I connect these two lines, what do I get? Well, I get a vertical line through 3. So what I would like for you all to know is vertical lines, all of them, have an undefined slope. So you quite literally just put m equals undefined. Okay, and you can see that there's a rise, but there's no run at all. So you can't do anything with this line. We would say it has an undefined slope because you can't climb this line. You can't walk across this line, okay? And what I would like for you to notice about this is the x's are the same. And when the x's are the same, if you get down here to this denominator of the fraction, when you subtract those x's, you're going to get that 0. The 0 tells us the slope is undefined. That automatically should tell you you're dealing with a vertical line. All right, so to sum it up, we have 3 types of slopes. Or 4. I don't know where I got my 3 from. So the first type of slope is a positive line. So M is positive, the line goes uphill. We had negative slopes. So M is negative, the line goes downhill. We had M is 0, the line is horizontal. So something like this. And then we had that the slope is undefined and the line is vertical. So you can have a positive slope, a negative slope, a 0 slope, or an undefined slope. And so you need to know what that means. Positive slopes, the line goes uphill. Negative slopes, the line goes downhill. 0 slope, the line is horizontal. Undefined slope, the line is vertical. And then also remember, the larger the number, ignoring the sign, the larger the number, the steeper the line. The smaller the number, the less steep the line is going to be. All right. So that's pretty much it for general just slope. So calculating slope. One other thing that can come up with slope is called rate of change. I might do a separate video on rate of change, but right now, rate of change isn't going to be super applicable at this point, just learning how to graph a line. So if it comes up that we need rate of change later, I'll reevaluate and I'll make a different video. But for now, this is the 6th video in the series. So the first video was what is the rectangular coordinate system? The second video is what is a linear equation in 2 variables? What do the solutions look like? The third video was horizontal and vertical lines. They come up repeatedly, as you've seen. Let's see, the 4th video was intercepts. So how to algebraically calculate intercepts, what intercepts are as far as the graph is concerned, and then using intercepts to sketch a graph. The 5th video was the point plotting method for graphing, which is kind of, we already had the pieces to do that. We just kind of had to put it together. So the point plotting method, you basically find 5 or 6 points, ordered pair solutions to the equation. You plot those, you graph, you connect with a line. And then for this video, we look just at the slope. So coming up, we're going to look at how would you graph an equation if all you had was a point on the line and the slope of the line. Then that'll kind of scoot us over to slope intercept form of a line. And then we'll talk about how to find equations, and then we'll talk about parallel and perpendicular lines, and then we'll wrap everything up as far as graphing linear stuff is concerned with graphing linear inequalities. Okay, so this is about halfway through the entire series. As you watch these videos, watch them as if you're in a classroom. Okay, take notes like you were a student. Write down the definitions, work the problems out on your paper as I work them out in these videos. Then you have this nice resource that you can go back to and study. All right, so again, next up, we'll talk about graphing with a point and a slope, but for now, take care. I hope these are helping.